Welcome to AI for Good, the leading, action-oriented, global and inclusive United Nations platform on AI. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with 40+ UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify innovative applications, build skills and standards, and advance partnerships to solve global challenges. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor.
Hi,
All right.
good afternoon. It's a great pleasure to be here. I think there was a sudden ending of the video, so I'll just, I guess, move on to my presentation.
Yes.
Is that right?
No, I will introduce you first.
Okay, all right.
Okay, all right. Okay, welcome everybody to today's webinar. My name is Alexander Winkler. I'm a group leader at the Max Planck Institute for Biogeochemistry. And I'm very happy to welcome today's speaker, Nuria Oliver. She is the director of the Alice Alicante Foundation, also known as the Institute of Humanity-Centric AI, and co-founder and vice president of Alice. She holds a PhD from the Media Lab at MIT, and she worked as a researcher at Microsoft Research. And she held positions in industry as a chief scientific advisor and director at Telefonica and Vodafone. And she's well known for her work at computational models of human behavior, human-computer interactions, and big data for social good. And in that, she received many awards. And she's very passionate about the potential of AI to be a driver of social good. And in that context, she will speak today about towards a more inclusive world, uncovering and addressing human and algorithmic limitations. And without further ado, Nuria, I would ask you to give your presentation.
Thank you very much, Alexander. So as I was saying, it's a great pleasure to be here today. And for the next 45 minutes or so, I will share some of the work that we are doing at Alice Alicante at the intersection between biases and AI systems. But before going into the subject matter, I thought it could be helpful just to give a quick overview of what Alice Alicante is. I assume you're seeing my screen correctly? Yes?
Yes, all good.
Okay, great. So Alice Alicante is one of 41 Alice units located in Alicante, Spain, which is a city on the Mediterranean coast. As you mentioned in the introduction, it has the nickname, so to say, of the Institute of Humanity-Centric AI. So I think from the title or from the name of the institute, we can see the clear focus of what our research is about. Alice Alicante is unique within the Alice network because it is the only Alice unit that was created from scratch as a nonprofit research foundation. And that's why Alice Europe calls Alice Alicante a startup unit. It is also the only Alice unit that has been created with a clear focus, which is to do research on AI to drive positive societal impact. It has a private-public funding model with a stable funding provided by the Valencian government, which is complemented with private funding. And we are also trying to be innovative in the way of doing research. So we have a very agile, focused on fundamental, not incremental problems, intellectually free, non-bureaucratic approach to doing research. These are just some pictures about the lab. We are located right on the harbor of Alicante, and I take the opportunity to invite you all to come visit us. At Alice Alicante, we work on 3 areas. The first one is called AI to Understand Us, and it's about building computational models of human behavior using machine learning methods, both individual models and aggregate models, and in all cases to drive positive societal impact and to support the 17 Sustainable Development Goals. During the COVID-19 pandemic, the only work that Alice Alicante did was on this area, and it was about using AI to make better predictions of the pandemic curve and to have a better understanding of the impact of the pandemic on people's lives. The second area is called AI that interacts with us. And here we study human AI interaction, and we are also developing novel intelligent interactive systems, including an educational chatbot. And the third area is called AI that we trust, and it's about addressing the main limitations of today's AI systems and also understanding their societal impact. Most of the projects that I will present today are on the last area, but also on the first area, because we are also modeling human cognitive biases. All our projects have some intersection with at least one sustainable development goal. Today, I will talk about diversity in AI and the social impact of AI algorithms in social media. I will talk about human cognitive biases and AI systems, and I will also talk about fair machine learning models. So let's get started. And the first project is about biases in social media, and this is part of the PhD thesis of Piera Riccio, one of our earliest PhD students. It is obvious that we live in a world of social media. There are more than 4.7 billion social media users in the world, which is almost 60% of the world's population. And we love our social media. Half of our time on our phones, and that was in 2022, today is higher, was spent on social media. An average user spends more than 2.5 hours daily on social media, and this amount of time is a lot larger for the younger demographics. Within social media, there is a very important aspect, which is self-representation. How do we represent ourselves in the digital world? And one trend that has been acquired a lot of popularity in the past few years is the concept of beautification. The fact that we can apply AI-based beauty filters to our selfies so we can present ourselves as more beautiful than we would be in the physical world. This phenomenon is extremely popular. At least 85% of girls have downloaded a beauty filter to change their appearance by the age of 13. And 90% of young women reported using filters before uploading selfies to a social network. These filters are obviously redefining what are the facial aesthetics that are valued, at least in the digital world, and they are having significant impact in society, as I will briefly explain. But first, let's see what these beauty filters do, in case some of you are not users of beauty filters. So the filters use computer vision algorithms and augmented reality to apply transformations to the face in real time, and in this case, to make the face more beautiful, according to some implicit canon of beauty that is defined in the filters. I'll show you an example with my own face. This will be my face without any filter applied to it. This is my face with one of the filters, and this is my face with another filter. As you can see, the filters tend to smooth the skin, increase the eyelashes, make some changes to the lips sometimes, or even change the eye color, like the filter on the right. These filters are posing significant societal challenges. There's been numerous articles describing the impact that they're having on self-perception, which is leading to dysmorphia, cognitive dissonance, and even an exponential increase in plastic surgery in teenagers. And something that was barely investigated until we did this work was a study on what were the actual technical characteristics of these filters. What do they actually do? And what kind of impact do they have? And that's what I will present, because this is what we have done. To be able to study these filters, one of the biggest limitations is a lack of data. There aren't any publicly available data sets of beautified faces. And of course, it is not ethical to scrape social media sites to obtain faces of beautified individuals. So we invented a system called OpenFilter that enables us to apply any social media AR augmented reality-based filter on existing public collections of faces, data sets of faces that can be used for research. With OpenFilter, we can take an input image, apply a filter to the image programmatically, and create the beautified version of this image. Using OpenFilter, we created 2 publicly available data sets of beautified faces, which are the beautified versions of 2 popular data sets. We call them Fair Beauty, which is the beautified version of fair face, and then BLFWA, which is the beautified version of the LFWA data set. This part of this work has been published in NeurIPS 2022. Then we have to figure out which beauty filters to apply to our faces. So we selected 8 beauty filters based on their popularity on social media. And we applied the 8 beauty filters to the fair face and the LFW data sets to create the beautified versions. Having this data set, then we wanted to answer 3 key research questions. The first question was, do filters reduce diversity? Do they somehow homogenize beauty and create a less diverse digital space? Second question was whether the filters impacted recognizability. Are people not being able to be recognized of who they are after the application of the filter? These 2 research questions are answered in the NeurIPS 2022 paper. And then we added another research question, which was about racial biases. Do the filters have any kind of racial bias? Are we equating being beautiful with belonging to a certain racial group? And we respond to this question on a paper published in Social Media and Society. There is a 4th research question that I will respond next, which is about the interplay between beauty filters and around cognitive biases. And the answer to that research question is published in a recent paper that we published at the Royal Society Open Science. So let's answer the first research question. Do beauty filters reduce diversity? To be able to answer that question, we analyzed 5 different versions of the faces. We had the original version, which is the one indicated here, the second column from the left. We have the beautified version using open filter, and we had like 8 different filters that we applied, but in a random order. Then we had 2 blurred versions of the images to see if the filters somehow maybe added some kind of artifact, or what was the relationship between the filters and blurring the images. And then we also had a downsampled version of the images. To be able to answer the first question, what we did was compare the similarities between pairs of images before beautification and the same pairs after beautification. If the filters reduced diversity and made everyone look more similar to each other, the hypothesis was that the images after beautification will be more similar to each other than before beautification. And then what we did was compare the differences between this distance metric between the pairs of images, and we observed that in all cases after beautification, the distances were negative, which means that the beautified faces were indeed closer to each other than the original faces. The result of the beautified faces is the blue bars, and as we can see, depending on the model, and we tried this on 6 different state-of-the-art models, in all of them, the beauty filters are homogenizing beauty, they're reducing diversity, and in many cases is similar to significant blurring of the images. So the answer of the first question is yes, the filters homogenize beauty. We also obtain statistically significant results in all the differences between the original faces versus the beautified faces. The second question that we wanted to answer was whether they impacted recognizability. Maybe they make us all look really beautiful, but then we are not recognized as ourselves anymore. We are recognized as someone else. Intuitively, we thought that this answer should be no, because otherwise people wouldn't beautify themselves. In many cases, people don't disclose that they have been beautified, and they want to pretend that this is their appearance in the physical world. So to do that, we tested 3 state-of-the-art face verification algorithms, both on the beautified and on the non-beautified versions of the faces, and we wanted to see if their error rate increased in the beautified versions, meaning that it was impacting recognizability. However, we found that the performance was significant, was quite competitive after beautification. This is the result for each of the 8 filters, and as you can see, is fairly high except for one of the filters, and still is very high performance compared to the original faces, which is the top row, where the performance was almost was above 99% for the 3 models: curricular face, mag face, and elastic face. So given this competitive performance being in all cases above 96%, we consider that the filters do not impact recognizability. And the third question was, do the filters encode any kind of racial bias? Are we somehow making any statements. Are these filters making any statements regarding what do we mean by being beautiful from the perspective of any kind of racial characteristics? To answer this question, we selected the same faces from the same data sets, and we tested two algorithms that are doing automatic race classification from faces, which is deep face and fair face. Similarly to the previous analysis, we compared the performance on 4 sets of images, the original image, which is on the left here, the beautified version, and then 2 blurred versions of the image. So let's see what we found. We found that, yes, beauty filters encode a racial bias. They actually make people look whiter. In this graph, we show the results for deep face on the left and fair face on the right. The graph has 2 parts. The part on the right shows the percentage of people that were considered white after beautification, the increase in percentage. And we can see that for some racial groups like Latino, Hispanic, or Middle Eastern, up to 30% more people, for example, for female Latino Hispanic, they were considered white after beautification. So indeed, there is a big change in the performance of the algorithms after beautification, confusing people a lot more as belonging to the white race label after beautification than before beautification. On the left-hand side is the same information. It just shows the loss in performance in the correct classification of the racial group after beautification. And we can see that in some cases, such as, for example, deep fakes for Latino women or fair face for Latino Hispanic men, for example, the drop in performance is very, very large. But we also wanted to understand how do these filters encode this racial bias. We know that people after beautification seem to be confused or seem to be perceived as whiter, but why? To answer this question, we created 2 different sets of images, the set C and the set F. The set C is the set of images for which both the original image, which is we represent as X, and the beautified version of the image, which is represented as XB, are both classified correctly. So there is no mistakes. The set F is the set where some flip in the decision has happened as follows. The original image is classified correctly as non-white, but the beautified version is classified incorrectly as white. So there is a flip in the decision, or the original image is classified incorrectly as non-white, and the beautified version is classified correctly as white. And we wanted to understand with these sets, if we were able to shed some light on how these filters, what kind of changes these filters are implementing that are kind of like confusing the algorithms and making people look whiter. To do that, we compared the performance in these 2 sets, the C and the F, according to 2 metrics. One metric is called the overlap, and the other one is the brightness. What the overlap is trying to measure is the following. And we can see with this example. Here we have the original face on the top, and on the bottom we have the beautified version of the same face. We apply explainable AI, a state-of-the-art method, which is an attribution map or a heat map that shows in which part of the image the algorithm is paying attention to determine the racial label for this person. And we can see that on the person on the top, it seems to be paying attention to the area in between the eyes, and the person of the bottom, it seems to be paying attention to the area around the mouth and a little bit around the eyes. The redder the pixels, the more important those pixels are to make the decision. With this heat map, we binarize it and we obtain these masks, which is basically the parts of the image that are the most important to determine the racial label on the top image, and then the parts of the image that are the most important to determine the racial label in the bottom image, as you can see here. And then we compute the overlap and the delta in brightness between these 2 masked, so to say, images. The overlap would be what percentage of pixels appear on both images here, and in this particular case would be 18%. And then the delta in brightness is the difference in the brightness between the patches in the beautified version versus the patches in the non-beautified version. The reason why we compute this is because one hypothesis could be that people look whiter because it whitens the skin and then everything is brighter. So we wanted to determine whether that was the case. So having these two metrics, we applied these two metrics to all the images in our in the C set and in the F set, and then we compare the difference, and then I'll show you what happened. So when we look at the overlap, this graph has a lot of information because it has two models, the fair face in blue and the deep face in orange, and then it has the overlap on the set of images where the system doesn't make any mistakes, which is the light color, so the light blue and the light orange, and then the overlap in the sets of images where the system flips the decision, which will be the dark blue or the red. And as we can see, the overlap on the set where it makes a mistake or flips the decision is smaller than the overlap in the cases where it doesn't make a mistake. And what this suggests is that the change in the decision is based using information from different parts on the image than those that were used when analyzing the original image. So the filter is changing really aspects of the face that is making the algorithms pay attention to different parts of the image after beautification. And then we also wanted to know whether those parts were actually brighter. And here our hypothesis is not completely corroborated because while the beautified faces, the patches that the system is paying attention to, they tend to be brighter, it is not necessarily always the case. So it's not just because the skin is brighter that the filters are making people look whiter. There is actually much more complex transformations that are being made by the filter that are confusing the algorithms and making people look whiter after applying the beauty filter. And in fact, we have many counterexamples of the hypothesis that maybe it's just because it's brighter. In this example, for example, we have the original and the beautified, the original and the beautified. And in these two cases, these are cases where the algorithm makes a mistake and classifies the beautified versions as white, but not the original ones. The original ones are properly classified. And in these cases, the facial features are the same, which in this case is this one, and in the case of the girl would be the nose. And in both cases, the brightness is actually the same. So it's not paying attention to different features, and it's not brighter, and still it is changing the decision. So this suggests that the filters make really complex modifications to the faces, to many of the different facial features, the skin texture, and so forth. And it's not just a simple brightening of the face. So to sum up this part, do beauty filters reduce diversity? Yes, they reduce facial diversity, something that of course is not desirable from a societal perspective. We should embrace and foster diversity, not the other way around. Do beauty filters impact recognizability? No, they don't significantly impact recognizability. You are still yourself. Is there any racial bias in the beauty filters? Yes, there is a wide racial bias. And the reasons for such a bias are actually complex, and they are not that simple. So this is the first part on beauty filters. Now I'm going to move on to the second part, which is connecting beauty filters with our own cognitive biases. And this is work by another of our Ellis PhD students, Aditya Gulati. As part of Aditya Gulati's thesis, and in general in Ellis Alicante, a fascinating research area that we're investigating is the intersection between human cognitive biases and AI. A cognitive bias, you probably know what it is, or you've heard the term, is a systematic pattern of deviation from what would be considered rationality in a decision or a judgment. We have many cognitive biases that impact our perception, our decisions, our memories, and so forth. There are authors that refer to this as irrationality. The theory of cognitive biases has been proposed, among others, by Nobel Prize winner Kahneman and Tversky in their 1972 paper. There is around 200 human cognitive biases that have been documented to date. So there is actually a lot. And cognitive biases are usually leveraged to take advantage of us. They are very well known in the casino industry and the gambling industry. There is a lot of biases that are used by casinos or video games to actually make us, spend more money or spend more time. They are very much used also in marketing, using very similar mechanisms, but they are also increasingly being used, for example, to influence elections. It's been documented that cognitive biases are impacting judicial decisions and also medical decisions. So it is absolutely necessary that we understand what is the impact of these biases, which are our biases, and particularly how we can actually help better understand and mitigate our own biases using AI. But also, it hasn't really been studying very much to date what happens when we are interacting with AI systems. Are we exhibiting the same cognitive biases or not? It is not very clearly understood. So in this research line, we are investigating this intersection. As I said earlier, there are 200 cognitive biases, and of course, we can study all of them at the same time. And given that we are fascinated by beauty, as I showed in the previous project, we decided to investigate one of the biases that is at the intersection with beauty, which is called the attractiveness halo effect. I don't know if you have heard about it. The attractiveness halo effect is a cognitive bias that says what's beautiful is good. It has been documented in numerous studies that people that are perceived as more attractive are also perceived as more hireable, more trustworthy. They receive more favorable, judicial sentences. They're more likely to get promoted, receive funding if they're asking for funding, receive credit. They are perceived as less likely to be criminals, etc. So there seems to be a lot of advantages just like from looking good. This is just an illustrative example. An average looking person might be given a sentence of 5 years. A not so looking person, and this is just Aditya's image, he put it as a joke, maybe he gets a 7-year sentence, and a really good looking person, will get a shorter sentence. So it is a very important bias to understand. As I explained previously, we can actually alter how attractive we are using beauty filters. So one of the questions that hadn't been answered to date was, what is the interplay between beauty filters and the attractiveness halo effect? Are we exacerbating the attractiveness halo effect from the fact that everyone looks beautiful, on the internet? So no one really knew. So a very long answer to this question is in this paper that we published a couple months ago in the Royal Society Open Science, and it has a very detailed explanation of the study and the results that I will present next. To be able to answer this question, we ran a very large user study, which we call the Beauty Survey. And in this user study, we wanted to answer several questions. Of course, the first question was, do beauty filters actually work? Do they increase attractiveness? Because maybe they don't. In the previous study, we never actually investigated whether the filters were increasing or decreasing attractiveness. Of course, attractiveness is a subjective measure, so we had to do it with a user study with people who had to rate the attractiveness of the faces. And we also were interested in understanding what was the role of the sex, the age, and the race of the individuals with regard to the impact of the filters and how attractive they were perceived. But then the most important question that we wanted to answer was, what happens when the same person is rated along certain attributes that have been documented to be part of the attractiveness halo effect, such as intelligence, trustworthiness, happiness, sociability? What happens when the same face, the same individual, is judged before and after applying a beauty filter? Is the same person perceived as more intelligent after applying the beauty filter just because it's perceived as more attractive, and there is the attractiveness halo effect? So no one really knew the answer to that question, so we wanted to answer it. So as I said, we ran this really large-scale user study. We had over 2,700 participants, and we also had a very large data set of images. So we had 462 different individuals coming from 2 publicly available face data sets that cover a wide range of racial groups, ages, and of course 50-50 in terms of gender. And we applied a very popular beauty filter to these 462 faces, and we obtained the 462 beautified versions of the same faces. Every participant rated 10 faces of 10 different individuals. They didn't know, but 5 of the individuals were beautified and 5 of them were not. We refer to the non-beautified, to the original faces as the preset, and the beautified set, like the beautified version, like the beautified data set, as the post set. The participants rated each face according to these different attributes: how attractive the face was. They also, we asked them to estimate the gender and the age of the person. And then they had to rate how intelligent the person was, how trustworthy, how sociable, how happy, how feminine, and how unusual. All of these variables on a 7-point Likert scale. We did 2 levels of analysis. We aggregated all the answers per individual, per face, and we computed the median scores because it was non-normally distributed, and we report the results on the median scores per face. But we also did an individual analysis per rater, and to do that, we did some novel statistical analysis that I will explain next to make it more scientifically robust. All right, so let's see an example, and this is a real example. So we have this face, and the median scores on attractiveness, maybe it was a 3. The median score on happiness was another 3, on intelligence a 3, on trustworthiness a 4, and on sociability a 4. Then we have the same person being beautified, and then the median score on attractiveness increased, which I guess makes sense. That's what the beauty filter is supposed to do. But also the same person with the same picture suddenly also became happier, became significantly more intelligent, equally trustworthy, and more sociable. So indeed, in this example, we see the effect of the beauty filter on the attractiveness halo effect. So let's see the results for the entire data set. First question, do the filters work? Do they actually increase the attractiveness of the person? And the answer is yes, the filters work. Here we show the attractiveness levels before beautification and after beautification. And as you can see, pretty much everybody increased the attractiveness levels. The green dots mean male, the fuchsia dots mean female. So as you see, the females tend to be rated as more attractive than the males. And there is only, I think it was 3% or 3-point-something% of the faces that did not increase attractiveness, but they stayed the same. So no one actually decreased the attractiveness because of the beauty filters. Moreover, we found, and I think this makes intuitive sense, that the less attractive you are perceived originally, the bigger the improvement or the benefit of the filter. Here we show the attractiveness level before beautification, and on the y-axis we show the improvement in attractiveness. And we can see that the ones that benefit the most are the people that were rated as the least attractive originally, which makes sense. If you're already very good looking to start with, it's going to be difficult to make you better looking. So the answer to the first question is yes, the beauty filters improve attractiveness. And then, of course, we wanted to understand if age, gender, and ethnicity matter. In terms of age, we find, yes, age matters. Younger people get higher attractiveness scores. We also found that the age group that benefits the most from the filters are actually the middle-aged individuals. Does gender matter? Yes, gender matters. I mentioned it in the previous image. Females are generally rated as more attractive than males, and they also benefit more from the filters. Does ethnicity matter? And this was a counterintuitive result. We found that no, ethnicity didn't matter. The scores on attractiveness before and after beautification were very similar across different ethnicities or racial groups, and we didn't actually find any statistically significant differences. So we know that the filters increase attractiveness, and we know that there is the attractiveness halo effect. What's beautiful is good. So does this mean that people are perceived more positively after beautification? Is the same person perceived as more intelligent after beautification than before beautification, or more sociable or happier? And the answer is yes. The attractiveness halo effect exists. It happens even after beautification. And not only people are perceived as more attractive, but they are perceived as more intelligent, more trustworthy, more sociable, and happier after beautification. After doing this analysis on the medians, which is the aggregate scores per face, we wanted to answer this question. Is beauty in the eye of the beholder? Does it matter who is judging you? To be able to answer this question, we had to look at the individual scores per rater, per participant in the study. But what we observed, or at least intuitively it makes sense, is that because these are all subjective measures, different participants could have different scales. The 7-point Likert scale might not be the same for everyone, because what is a 3 for me, it could be a 4 for you, or vice versa. So we applied some sophisticated methodology called order stereotype models to automatically infer the right scale per attribute and rescale all the answers according to these attributes. And this is an example of how one scale, which would be the regular Likert scale, is at the bottom in black, which would be the 7-point Likert scale. For one particular attribute, in this case is attractiveness, we see that in the set before beautification, which is the orange, we find that the 6 and the 7 merge, probably because the attractiveness is shifted to the left because this is before beautification. So there aren't that many people rated 6 and 7. So automatically the algorithm merged those categories. And as you also see, the distance between the points is not equal. They are not equidistant points. It is harder to move, for example, from a 4 to a 5 than to move from a 3 to a 4. This is before beautification. And after beautification, you see the scale here, instead of being a 7-point Likert scale, is a 5-point Likert scale, where the bottom part of the scale, 1 to 3, gets all merged because everyone is more beautiful. So there aren't, it doesn't matter, like 1 to 3, they all become the same dot. This is an example of applying this on attractiveness, but we did it on every variable, and then we build generalized linear models to understand the influence of the different variables, like the gender of the rater versus the gender of the image, the attractiveness level of the image, the age of the rater versus the age in the image, and then the joint impact of the gender of the image and the gender of the rater and the age of the image and the age of the rater. We didn't consider the racial group because we've had reported earlier the racial group didn't matter in terms of the scores. So what did we find? Does it really matter who is looking at you? Is beauty in the eye of the beholder? And the answer is yes. Beauty is very much in the eye of the beholder, particularly given the gender of the rater and the gender of the individual that is being judged. Here we show for attractiveness, the ratings before in orange and in purple after. On the x-axis, we have the gender of the rater. So these are female raters versus male raters, and the colors indicate images of females versus images of males. And we take as a reference images of females rated by females, which would be this pink dot. And what we see is that there is a gap. So females rating males, they rate them lower in attractiveness than females rating females, and then male rating males also give lower scores than males rating females. So in general, as I already reported, females tend to get higher attractiveness scores than males. We have the graph before and after beautification, and we see, for example, that the gender gap, which is the distance between the pink line and the blue line, gets a lot wider after beautification. So the women are perceived as more attractive than the men, both by males and females. And where there are stars, it means that the differences in the scores given to males and females are statistically significant with a p-value of 0.001. So yes, it matters who is judging you in terms of attractiveness, but we also found that it not only matters in terms of attractiveness, but it also matters in terms of other attributes. So this is the results for intelligence, which are the most surprising and I think the most socially relevant results. What we find here, and you can see it in the graph, is that as opposed to attractiveness, where females were considered more attractive than males and the gap got larger after beautification, we find that in general, males are perceived as more intelligent than females, and the gap increases after beautification. Moreover, females rated by males are perceived as less intelligent after beautification than before beautification. Like the difference is much larger between the two genders after beautification. So there is another bias that seems to be stronger than the attractiveness halo effect, which is the gender bias, which somehow corresponds to the stereotype of maybe a dumb blonde, like if a woman is too beautiful, she cannot be intelligent. And we have various substantial empirical evidence of actually that phenomenon. This doesn't happen with other attributes, such as, for example, sociability, where we do find that women are perceived as more attractive and they're also perceived as more sociable. Interestingly, after beautification, when rated by males, both females and males are considered equally sociable. So males seem to benefit a lot more from the beauty filters regarding the attractiveness halo effect compared to females. The last question that we wanted to answer was if maybe beauty filters could somehow mitigate the attractiveness halo effect, because there is a limit on how attractive you can be. And maybe if they democratize beauty and they make everyone equally beautiful, the gaps and the differences between the perceptions of the other attributes would get smaller. So we do find evidence about this. We call it the saturation of the halo effect. Indeed, we find that the strength of the attractiveness halo effect, even though it exists, it is weaker after beautification. So there is saturation, so to say, on the curve of intelligence versus attractiveness, as we can see here in this graph here. And this is particularly more pronounced after beautification. So indeed, it seems that the filters would perhaps weaken a little bit the attractiveness halo effect, but this doesn't happen with other attributes, for example, sociability, where the size of the effect is very similar. And this indicates that maybe the filters could be used to mitigate the attractiveness halo effect, but we have the challenge and the issue related to the gender bias and how they negatively impact the perceptions of women when it comes to intelligence. So as a summary of the findings, beauty filters do increase the perceptions of attractiveness. The same individuals are perceived as more intelligent, trustworthy, sociable, and happier after beautification. Age and gender matter, ethnicity doesn't matter. Beauty filters partially mitigate the attractiveness halo effect. They exacerbate female gender stereotypes. And of course, there is a clear need for transparency and ethical guidelines surrounding the use of beauty filters. This paper, which was published on November of 2024, has received a lot of attention, is in the top 5% of impact, according to Algorithmic. And of course, I'm not going to claim that it is because of our research, but I want to believe that maybe our work has contributed a little bit. As you probably followed, a few months later, and two very large social networks decided to regulate the use of beauty filters because of the negative consequences of them. Regarding this topic, we are now investigating the existence of the attractiveness halo effect in generative AI algorithms. And we have created a term which we call algorithmic lookism, which would be the existence of lookism in AI-based algorithms. And we can have two types of lookism. A lookism in generative models, which would be that when generative models are creating images, they are actually reinforcing stereotypes regarding the looks and the attractiveness. And then we also have algorithmic lookism in a discriminative fashion, which would be that when we have a multimodal system that is trying to make decisions, is trying to judge faces. For example, it could be in the context of a curriculum, in a hiring application, or in the context of some policing decisions analyzing the profiles of certain accused individuals and so forth. We want to know whether the algorithms are also subject to the attractiveness halo effect, if they actually provide different judgments of the same individuals before and after beautification. And this is what we are working on right now. I just wanted to give you an illustration of the existence of algorithmic lookism in the case of generative AI. We have, these are examples that I created using DALL-E 3. I asked the system create a hyper-realistic portrait of an intelligent person, and this is what it creates. Obviously, having a lot of books somehow makes you more intelligent, and also wearing glasses. Then an unintelligent person, this is what it created. They still wear glasses, but definitely they need to care more for their hair, and the books are all messy. A very competent person, very clean, very professional looking individuals, and a very incompetent person. And this is what the system created. So there is plenty of evidence that the multimodal, both generative and discriminative systems, they also seem to be subject to the same cognitive biases that we humans have, and that's why it's important to study them. I had another project to present, but I see that it's already 6 p.m. And if we want to have time for questions, maybe I will skip this project. If there is interest or there aren't any questions, I can explain it. It is about algorithmic fairness, and it is about one particular topic that hasn't been studied very much on algorithmic fairness, which is fairness in social capital in graphs. But I will skip it for now. And if there are questions, if there is interest, I can explain it. And I guess I'll just go to the end of my presentation. These are relevant publications. And the last thing that I wanted to mention, given the timing, is that we have an upcoming event at ELIS Alicante. We have a webinar on Wednesday related to two interesting projects in the intersection between generative AI and people. There is also a very interesting open call right now for any mid-career scientists who might be interested in relocating to the Valencian region of Spain. It's called the Valer program, and they offer very competitive salaries as long as you have a host institution. And we at ELIS Alicante are a host institution of potential candidates to this Valer program. And if you want to keep updated about our news, I also encourage you to subscribe to our newsletter. And this is all part of our website. And I skipped the relevant publications, but I put them now. So a lot of the work that I've presented today is being published on a variety of different papers in scientific conferences and in journals. And the open filter and the data sets are also freely available on our website. Thank you very much.
All right. Thank you so much for this very nice talk. I would now encourage to all who are listening, please type in your questions so that I can pass them on to Nuria. In the meantime, I already have a first question from my side, and that is, in your survey, you conditioned on gender. Were there also other categories you could condition on besides gender?
You mean of the rater or of the
Yes.
of the face that was being judged?
No, that basically the people who judged.
So the people who judge, we also explore the impact of their age.
Yes.
I didn't include it in the presentation because the presentation will be too long. And we had 3 different age groups, young, middle age, and old, and we found some effects depending on the group and the age of the person that was being judged as well. But I presented the gender results because first of all, it's easier. There's 2 genders. Is the combinations are smaller, but also because we are the first to report the existence of the gender bias in conjunction with the attractiveness halo effect and showing this negative impact that it seems to have on women regarding intelligence. So I decided to focus on that on my presentation, but in the paper, we also have information about the role of the age. As I said, we didn't study the ethnicity because we found that the ethnicity didn't seem to play any role in the judgments. And regarding the ethnicity of the raters, and we explained that as a limitation of our work, all the participants had to be native English speakers because the study was in English, and they were coming prominently from the US and the UK. And we did have some diversity in terms of the self-declared racial group of the participants, but it was majoritarily white people. So we didn't have a balanced sample of raters from different self-declared like racial groups. Yeah.
So there's some cultural bias basically in this.
Yeah, well, because of the English limitation. Yeah.
So when
But
you
yeah.
No, please go ahead.
No, but the part that was interesting was in the literature. So one of the elements that was, I think, very valuable from our study is that in the literature, there have been a lot of conflicting findings for all the questions that we address. So there had been conflicting findings in terms of if the same individual is improved. Of course, before using beauty filters, people were applying makeup to the same person. And then, of course, they had one person because it's very expensive to apply makeup. They were doing the studies in the physical world, usually with psychology students, and they had very small samples. So we really took it to a different level, the entire kind of like knowledge of the attractiveness halo effect. So there was conflicting results on whether applying, improving the same person, whether, the person is perceived as more intelligent, etc. The same person after beautifying it's her or himself or not. And we do find conclusive evidence that yes, you improve. There were inconclusive results or contradicting results regarding whether what is the role of the gender of the rater versus the gender of the subject that is being judged. There was a lot of conflicting results. Some people said that opposite genders, matter, but same gender no. I mean, it was really all over the place. So we really tried to find conclusive results about that. There wasn't really much anything super conclusive. There were some hypotheses on whether if you are judging people that belong to a different racial group than your own, somehow you don't have the same scale, and then there could be some factor there. We didn't find that. We didn't find empirical evidence about that because most people were judging individuals from all sorts of different racial groups, and we didn't find that matter. We got like the same results, so we didn't find evidence for that. So there is a lot of contradicting evidence from the literature that we were able to discern. I personally don't think that there will be significantly different results if the study were to be done, say, with Spanish speaking or, but of course we'll have to really be certain we should repeat the study, in other languages and, people from other cultures. And if anyone here is interested in collaborating on that could be interesting. And then it could be a really large scale study on this particular cognitive bias.
Thank you so much. So maybe I follow up with another question. So when you ask the generative AI to produce images of what is an intelligent looking person, all these persons had glasses. And I wondered, maybe you mentioned it and I missed it, but did you look into the aspect if people wear glasses or not? How it sort of conveys
No, so
intelligence?
the faces that we use in the human study were faces, as I mentioned, that were coming from two publicly available data sets. I didn't mention the data sets. It's the Chicago Faces data set and the Faces data set. There is a data set called Faces. And these data sets have been designed for research on faces in computer vision, to build all sorts of different algorithms, that analyze faces. The reason why we had two data sets was because one data set had a racial diversity, but not age diversity, and the other one had age diversity, and we wanted to make sure that we had both. They were both gender, they were both balanced in terms of gender, but not necessarily in terms of age or in terms of race. And as you saw in the pictures, it's a very controlled environment, so everyone has to have a neutral expression, which was very useful for us because there are studies that show that if you smile, obviously you look happier. We were asking for happiness as one question, so, and also if you smile, you look more attractive. So we wanted to make sure that everyone had exactly the same expression, exactly the same background, and exactly the same t-shirt. Like if you saw everyone is wearing exactly the same clothes. So, and no one is wearing any prominent makeup or anything. So the data set has been collected very well in a very controlled situation in such a way that the only change was the application of the beauty filter.
Yes.
And there was no other, change across the images. So for us, that was very important. So none of the images had glasses. That would have added another factor for us to control, which is whether the person has glasses or not, right? So in our study, no one had glasses. Everyone had to have a neutral facial expression, the same lighting, same background, same clothing, to control for all those variables, which we know impact our perception of faces.
Yes. All right. Thank you so much. So we have now a question from our viewers, from Lamin Ann, and thank you for the presentation. And she has two questions. The first one is, does the model also consider the age, race, and ethnicity of the person?
Of the rater or of the image that is being judged? Yes. But as I said, because we found no impact of the ethnicity, or in this case, in these data sets, it's called a race label. We use the terminology of the data sets because we didn't find that mattered. All the subsequent analysis was done taking into consideration the age and the gender, both of the images and of the raters for the individual analysis. For the analysis, that was the aggregate analysis of the median scores assigned to each image. That, of course, we don't consider the raters anymore because we are aggregating across all raters. And then we did consider the age and the gender of the individuals that are being judged.
All right. I hope that answered the question. And the second one was, can we have access to the slides?
Oh, yeah, I don't know how this works. Like, I guess you guys, I don't know, or the person can email me. My email was, I can share my screen again. And in my last slide, there was the email, so I can just share. Let me just share my screen. And then you can see my email there. But my email is very simple. It's just my name at Elis Alicante.
I just got the information that the slides will be added to the website.
Here.
And can be downloaded there.
All right, so here it is.
Yes. Oh, perfect. Okay.
It's a pity that I didn't have the time to explain the other project, because the other project is really cool. It's about social capital in networks, and how to improve the social capital.
Maybe you come back soon and give another talk.
Next time.
But I have another question, and that is, so the first project was really about this racial bias, right? And then in your survey, if I got it correctly, it didn't really show up, no? Because you looked into the different the effect.
Well, it was the racial bias of the filters. So what we tried to see was when you classify automatically the race label of a face using two different algorithms, deep face and fair face, do they make more or less mistakes, and which mistakes they make when they assign a racial label to an individual face? Is there any difference between before and after beautification? So this was algorithmic bias, right? We didn't do anything algorithmic in the other work. The other work was human people rating, right? And we didn't ask the people, so we didn't look into if people were rating the racial group of the individuals differently before and after beautification, which would be the equivalent of humans, right? Because the focus of the other work was on the attractiveness halo effect and finding substantial evidence about the attractiveness halo effect. So this is important to clarify. All the first part was about algorithms and how algorithms are impacted by the beauty filters. The other part was about humans and how humans are impacted by the beauty filters. And I think they complement each other very well, because of this reason.
There might be a signal in there.
Yeah.
All right. I think we have to close very soon. I would have more questions. I think what really would be interesting to me is that sometimes if people use these filters, for me at least personally, they also use a bit the trustworthiness because they look less real. I don't know if that was also something you found in your data.
Well, we did have a question on unusualness, which was a little bit related. Like, we were trying to see if somehow people were perceived as more unusual. after applying the filter or less unusual? We didn't know. Like on the one hand, you could say, well, if it homogenizes everyone, maybe they will be less unusual. But then on the other hand, you could say, well, if it makes everyone being so extraordinary, maybe they look more unusual. So it wasn't clear, but we didn't find super consistent results on the unusualness. So the unusualness and the femininity, I think we only reported in the appendix of the paper, because the other reason why we asked for femininity is because there was some hypotheses postulating that maybe the filters make everyone look more feminine, because the canon of beauty maybe is more of a feminine canon of beauty. So we wanted to see if that was the case. I think we did find a little bit of evidence that maybe a little bit, but it wasn't so super conclusive. And because none of them, unusualness and femininity, are part of the attractiveness halo effect, because there isn't necessarily a quality of good being more feminine or less feminine, So the attributes that had been extensively studied in the context of the attractiveness halo effect in the literature were intelligence, sociability, trustworthiness, and happiness. And those are the four that I reported the results on. But in the paper, I think in the appendix, we also included what happens with unusualness and femininity. And maybe unusualness is a little bit related to what you say. I mean, do people look not so real because everyone is so perfect? I think probably, but it is very difficult for humans to repeat ourselves all the time. These faces are beautified, these faces are beautified, this is not real. So when you look at yourself in the mirror, you feel very disappointed about all your imperfections. And this is really worrisome, of course, and, something that definitely needs to be investigated. One of the biggest challenges, and that's why we decided to do this research, as I mentioned in the intro, is the lack of data. It's just, this is all proprietary data from the proprietary social platforms, right? So it's really impossible to do large-scale quantitative studies on this properly, and that's why we had to create our own data. But I think the beauty filters are a reason for concern socially, particularly for girls and for teenagers.
So we have a few more minutes then. I just read that. We got a few more minutes, and I hope you still have a few more minutes to answer another question from the audience, from Sati Mokgoro. I hope that was pronounced correctly. And the question is, as AI systems become more advanced, how do you see the role of human intuition in decision-making evolving? Can we rely more on AI, or do we need to ensure human oversight remains central?
Well, it's a very good question, and that's why we are investigating the interplay between cognitive biases and AI systems, because I think we are very vulnerable to manipulation. I think today, a lot of machine learning algorithms that are embedded in many of the digital services that we use take advantage of our cognitive biases. I mentioned, casinos, marketing, but also apps. I mean, most of the apps take advantage of our cognitive biases. So with this line of work at ELIS Alicante, what we want is to take a different approach, and on the one hand, see if we can leverage AI to help us humans better understand our own cognitive biases and mitigate our own cognitive biases better. B, to also understand to which degree these cognitive biases are being propagated into the AI systems and algorithms that we are building and we are deploying. C, if we can actually use machine learning algorithms to protect people from being taken advantage by other AI algorithms that are trying to take advantage of us. And D, to which degree some of the heuristics and principles in the cognitive biases could be useful to create more efficient AI algorithms. Because if these cognitive biases are so bad, I mean, you might be questioning, why do we have them? Why do we have 200 of these biases? I mean, they seem to be making us make the wrong decisions all the time, right? They obviously have to have some reason why they exist. And one of the main hypotheses of the reasons why they exist is because they are shortcuts in our decision making, and they make us make decisions a lot faster and more efficiently than if we had to optimize a very complex multidimensional function every time we had to make a decision. So they really are leveraging all these different heuristics, and then we make decisions really fast. In many cases, in a non kind of conscious way that then we explain, using, our higher level of cognition. So if they're helping us make fast decisions, and not get, I don't know, run over by a car because I'm considering all the options of what should I do? Should I run? Should I jump? Should I immediately react? So maybe we can leverage the principles of some of these cognitive biases to create more efficient, AI algorithms. So the answer to the question is, yes, I think we are vulnerable, and it's an area that we should invest on. And from ELIS Alicante, we believe that we don't believe in technological determinism. We don't believe that there is only one way to develop technology. We believe that there are many ways to develop technology. And what we are trying to show is that we should always develop technology that places humans individually or collectively and the planet as the core and the important aspect when developing the technology. So every project we do is trying to address this issue, and maybe other people feel inspired by my talk and want to also collaborate or study this area.
Yeah, that's a very nice statement to end this webinar. Thank you so much. Thank you so much for your nice talk.
Thank
you.
you
Thank you so much for this nice discussion now. And also thank you everybody for joining. And I hope you join again next time. And by that, I wish you a very nice afternoon, evening. See you next time. Thank you so much.
Thank you, Alexander. Thank you for moderating the session.
Yes. Thank you,
Bye.
Bye.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.